Hi, everyone. We have a quick announcement before we get into the show today. SmartLogic, a custom web and mobile development shop behind this very podcast, is currently hiring. We're looking for a staff engineer with experience in Elixir, Ruby, Flutter, and more. Our team is fully remote, and we're open to applications from anywhere in the United States. You can read the full job description and apply at smartlogic.io/jobs. Now, on to the show. Welcome to another episode of Elixir Wizards, a podcast brought to you by SmartLogic, a custom web and mobile development shop.
This is Season 10, where we are looking to the next 10 years of Elixir.
We'll be talking with our guest about what the first 10 years might tell us about the future of Elixir. Hey everyone, I'm Owen Bickford, Senior Developer at SmartLogic.
And I'm Dan Ivovich, Director of Engineering at SmartLogic.
And we are your hosts for today's episode. For episode 6, we're joined by Mat Trudel, author of the Bandit library and Phoenix team member. In this episode, we're discussing the next 10 years of Phoenix and web transports. Hey Matt, how are you?
I'm doing great. Thanks for having me.
So before we get into all the weeds of Phoenix and web transports, for anyone who hasn't heard of you or seen your talks or read what you've been working on, can you give us a brief introduction?
Sure. So during the day, I'm a mostly back-end senior developer at PagerDuty. We're one of the quiet Elixir shops around. I often think that we're one of the largest Elixir shops. I've never actually verified that, but we do have upwards of 1,000 engineers working in Elixir as our primary and only back-end language. But anyway, that's my day job. In the evenings and the weekends, I've been working for the past few years on an Elixir HTTP server called Bandit. Bit of a backstory to it that I'm sure we'll get into at some point. Started off as a bit of a joke, is the short version of it, and has since become something that's rather more serious than I think I was ever expecting it to be. And that's been sort of taking up a lot of my free time over the past few years, working towards a number of the new features that it supports, most notably the fact that we now fully support Phoenix. And as part of that work, I did some work in the Phoenix project as well late last year to land that support.
Awesome. So yeah, I'm absolutely excited to talk about how things are changing a little bit with Phoenix and some of the new tech that we're maybe getting to play with a little bit. I'm also curious if for anyone who's not familiar, I've heard of PagerDuty. I have not fortunately been on PagerDuty for a while, but what does PagerDuty, the company, do, and how is Elixir involved there?
The original way the company started was essentially what the name says, right? It was a tool to manage being on call and to, route notifications to the right person depending on who's on call and how things might get escalated if someone doesn't happen to be answering their phone at 2 a.m, that sort of thing. The company more broadly, I think, is looking more towards, they call it digital operations. I'm sure that there's the PR folks are probably going to come down on me with a sack of hammers for misstating this. But the general idea, I think, is that we essentially run digital operations for companies. So we're more of a back end for people to be able to route messages and, route unplanned work throughout an organization. So Elixir fits very well with that, I think, just because it's largely very asynchronous, right? The things that it does well and that it does naturally are things that are very difficult in a lot of other languages. I think for the classic Elixir developer that might have come from a Ruby shop, had all of these tools in their tool belt for doing queued work and having job runners and rescues and all those sorts of things. And it often kind of felt like you were using perhaps the wrong tool for the job a lot of the time, whereas with Elixir, it very seldom feels that way. I was describing the language a few weeks ago to a friend of mine who works for an agency, so he just does JavaScript work, and he's heard of Elixir but has never worked with it. And I kind of described it to him as building blocks for computation, right? If you need to do something here, you can do it. If that happens to be from a web request, that's great. If it runs on a timer, that's fine too. If you're kicking things off in an O-band or something like that might have more complicated flows or like a gen stage pipeline or something. So that's maps very naturally onto a lot of the realities of, the air quotes digital operations world. It's a very natural fit for us.
Awesome. You've just thrown out a bunch of topics we could go in depth on for about an hour. Everything from, I know we've talked to some folks about Oban in the past, Gen Stage, definitely done some hacking with that over the past year or so. But today we're focused on Phoenix and how the web stack might be evolving a little bit. So how did you first get interested in the transport layer of the web stack?
So It's actually, this is the origin story that I said was a bit of a joke. So I originally started writing Bandit about 2.5 years ago, maybe 3 years ago. I don't know. Since the pandemic, time has no meaning. Maybe it was 3 years ago. And I wrote it essentially because I wanted to we have one of those wall-mounted air conditioners in our house, the ductless air conditioners, the heat pump things. And to be able to control it, it doesn't wire into your thermostat like a furnace might. It has like a handheld remote control, right? That looks like something out of the 90s. And we wanted to be able to control this thing from our phones. So I wanted to be able to turn it up and down when we're coming back from a road trip or something, so that we, arrive back to a nice, warm or cold house as it might be. So I started looking at doing that against a Raspberry Pi. So essentially running a Raspberry Pi with a little infrared emitter on it that could learn the infrared, the IR codes for the remote, and could fire messages off to the air conditioner. And I wanted to get that running over HomeKit, over the Apple HomeKit system. We're like an Apple family here, and that's just naturally what everything else in the house runs on. So I started looking at, they publish a guide for hobbyists and makers to be able to interact and integrate with the HomeKit ecosystem. And as it turns out, HomeKit devices in your house actually run an HTTP server on them, at least the ones that run on Wi-Fi. What'll actually happen is your phone or your iPad or whatever you're using will find these things over multicast DNS, and then it will essentially connect to them via HTTP and make HTTP requests to them. There's a couple little wrinkles with it though. So I started doing this and I started just using the standard Cowboy stack for this on top of Nerves. And I realized pretty quickly that there's a couple of wrinkles at a really low level. The protocol mandates, for example, that there's like some bespoke encryption that it runs on the TCP connection itself. This is not SSL. It's kind of Apple's, and there's a variety of valid reasons that they do this, but it's a thing apart from SSL. It's kind of its own little bit of encryption on top of TCP. And so I started doing this and realizing that I spent a couple of evenings trying to inject this relevant little bit of code into Ranch to be able to do that encryption. And I just gave up on it. I found it really, I was doing this for fun and it wasn't fun. So I got the idea of, well, maybe I'll just write my own transport server or my own transport layer. And then that required me to write my own web server on top, because you can't just replace, a single layer of the cake. You have to, write the whole thing. And so the next thing I'd been started writing, like the original 0.1 series of Bandit was released exclusively to be able to power this HomeKit library, which is another library that I maintain. It's called HAP, H-A-P, that provides Elixir support for HomeKit appliances. Today, it runs a bunch of other stuff in our house. It runs like our skylight blinds, thermostat in our house in the basement. It still actually doesn't, I've never actually written the bit for the air conditioner. So the original project is just on a shelf somewhere. I'll get to it eventually. But I kind of realized pretty quickly once I'd been doing this that, the actual crown jewel, as it were, of the stack wasn't so much the HomeKit stuff. It was the web server that kind of came along for the ride. And I more or less turned my attention towards that and have been kind of hacking on that for the past couple of years. It initially just supported basic plugs, so like the simple plug API. And I've been growing that out over the past 12 or 18 months or so to support the full extent of what Phoenix does, which is, for the most part, plugs, at least on the HTTP side, but the WebSocket side of the Phoenix world was where there was a lot more work to be done. And so that was the work that I've done that I think we'll probably end up talking about later on, that ended up culminating in the release of the WebSock library, which is now a project that's maintained by the Phoenix organization. And it essentially, you can think of it basically as the plug API, but for WebSockets. So it's the same notion of providing a generic abstraction for WebSockets, the same way that plug provides a generic abstraction for HTTP, and allowing application servers to plug into that. And as of Phoenix 1.7, that is how Phoenix 1.7 does WebSockets now. The WebSocket layer in Phoenix is built on WebSock. There is no more Cowboy specific code in Phoenix. That kind of is the bit that allows Phoenix to unlock support for other servers like Bandit.
So you had kind of ongoing efforts then here, right? Like a little bit of like Phoenix changing so that it could accept other things, and you writing this compliant core.
Yeah. And in fact, there's a whole, again, to Owen's point about being able to, rat hole on anything for an hour. There's a whole kind of story to be told, I think, about how that landed. This happened around November, December of last year. One of the great things about working at PagerDuty is that they run twice a year hack weeks that are just kind of, wide open. You can work on absolutely anything you'd like. And so I use those as really focused time to be able to work on Bandit. So you can see kind of the progress of the library is, incremental throughout the year. And then once a year, I just finished one in March, and then there's going to be another one in September. So like twice a year, there's these bumps where there's just a flurry, mad rush of activity. And so this started at last fall's Hack Week, where I essentially did some sketching to figure out what this abstraction would look like. But there's a lot of moving parts to it, right? Like I, first off, needed to look at Phoenix and figure out how it actually talks to Cowboy, which is, it turns out the WebSocket support in Phoenix prior to 1.7 was Cowboy specific. There was bits in the Phoenix WebSocket implementation that actually hard-coded, because it's an Erlang library, so you talk to it like via :Cowboy. So it was like :Cowboy, send, and it kind of has a different bit of the language of Erlang seems to have a bit of a different cadence to it, the way that they name functions and things just look differently. Capitalization's different, that sort of thing. And so there was these bits in the middle of Phoenix that nobody had really touched in a substantive way in years that were essentially hooking into pretty low-level stuff in Cowboy's Erlang stack, specifically for WebSockets. And so figuring out how to build an abstraction around those, pulling that abstraction out into a separate library, writing an implementation of that, first off, getting Phoenix to talk to that abstraction, and then landing support for that, to be able to host that abstraction, both within Bandit, but also within Cowboy, right? Because the reality here was that as much as I'm the author of the Bandit library, I also had to, the work that I was doing, I also had to shim into Cowboy. Like I also had to, play for the other team, as it were, for a little bit. And so that work took quite a while. That took me through the better part of October and a little bit into November, I think, of 2022. And it kind of culminated, to your point, in, I think there's about a half dozen or so PRs that needed to be landed in a really specific order that both ensured that earlier Phoenix installs continued to work and didn't break, the newer ones used this new stack, and that nothing there were no points along the way where you needed to use a specific version of a library and not have the other one up to date. So it was a bit of juggling to get that landed, especially considering that the majority of this work I was interacting with Jose for. I'm North American Eastern time, and he is, I believe, in Poland. There was kind of this thing where, I'd do a bunch of work at night, and then I'd wake up in the morning and I'd have a bunch of reviews from him. And then I had this kind of golden hour in the morning where if I could turn stuff around by about 10 a.m. or so, I'd have a hope of being able to get another kind of round of feedback and another round of iteration on it. But that stuff, like I say, it took about maybe a month or so of back and forth to kind of land that. And I'm frankly shocked at how well it came off. Phoenix 1.7 runs on this stack, period, full stop. There's no opt into it. This is what it does. And there hasn't been so much as a single GitHub issue about it, which has been quite encouraging.
Props for you.
That is a huge accomplishment.
Yeah. It sounds like changing the tires of a truck while it's rolling down the highway.
That's exactly what it was, right? That's exactly what it was.
We talked to a lot of people in the community around this. And I think something that I'm hearing that feels very unique to your experience. We talked to people, especially this season, about the future. What do you want to see? What are you hoping for? A lot of times it's like, the language is pretty good. We have what we need, and I'm sure something new will come along, but hey, it's great. But listening to you talk, you are constrained not just by what does Phoenix do or what does Erlang do, but also what do these protocols require? What do browsers do? So what's it like working on something with such a deep spec, with such a huge surface area that's completely outside our community's control?
Right. Yeah. I mean, there's actually a really interesting couple of PRs, or a couple of issues in PRs that came out around this. When I said that there hasn't been a single issue, there actually hasn't been one on the core of the issue, but there was, I can't remember who it was. One of the Phoenix core team members was working up support for a better handling on the client side of Phoenix when a user purposefully navigates away from a Phoenix application. And the WebSocket, RFC 6455, I think, is the official spec for WebSockets. And it's a little bit underspecified in a couple of ways. There's a couple of places where you could make a valid interpretation about which of the choices that are offered to you that you could do. And specifically, they have what they call in WebSockets are close frames. These are frames that one end is supposed to send to the other when it decides to leave a connection. And they have a code. They have just a numeric 16-bit code. And I think it's 1000 is like a normal shutdown, and 1001 is 1000 is a normal termination, and 1001 is a shutdown or something like that. And then they never actually specify how those are different semantically, like what semantically the difference is. And it turns out that everybody in the world uses 1000 for this, except for Firefox. They are the only outlier in this, and they send a 1001. Or maybe I have it backwards. I can't remember the exact details. So there's this back and forth where Someone was saying, I want to be able to add support to be able to send a specific code from within a Phoenix application specifically because of this allowance for Firefox. And we ended up accommodating it in the WebSocket spec. Like we did a backwards compatible adaptation for this that you can now specifically specify codes when you're closing a connection. But there are like these kind of outliers for this, right? Like, and you see this, I mean, at least in the browser world, the reality is that for the most part, we're pretty homogenous, right? Like everybody uses WebKit or Blink or whatever you want to call it these days. An awful lot of their pedigree is shared. And Firefox is kind of off in the wilderness doing their own thing. So you'd see these things, right? And they weren't wrong. They were just different, right? Like they were just reading the spec and making a decision a different way. You do see things like this, on occasion. I'm working through a bug right now that I think has something to do with an Envoy proxy that someone has filed as a bug against Bandit rather, that I believe has something to do with Envoy. I haven't quite nailed it down yet. Like there's places where people make different choices on these things, but that's the reality of open standards, I guess.
So then does the rise of live view kind of then and the reliance, kind of everyone making more use of WebSockets, is that another kind of like serendipitous moment of all of this kind of coming together with 1.7? Or do you think this would have happened regardless of the reliance on WebSockets in live view?
It probably would have happened regardless. The reality of writing infrastructure code like this is that if you do your job well, nobody notices, right? It's not a very glamorous line of work, especially to pick up as a hobby, right? And so the amount of not attention's the wrong word, perhaps. Awareness, even within the core team, for example, has been pretty modest. Nothing really changed for people, right? And this is like the big sell that I have, in the Bandit README when I walk people through how to update their project to start using Bandit, is you add a line that says adapter : bandit.phoenix adapter and you restart your server, period. Nothing else changes.
Mm-hmm.
It is today as it was yesterday and as it will be tomorrow kind of thing. Continues to happen. So the core team, to answer your question, I think they would have come against this because they were solving a different problem. It just happened to be that like WebSock was in the middle of it now, as opposed to the Cowboy specific stuff that was in the middle of Phoenix before.
So what should a average Phoenix developer, someone using the framework, know about HTTP or the transport protocols at all? Why does this matter to them? Like you said, you make the change and no one notices, and that's success.
Yeah. For
our average listener, like what should they understand about this and its importance?
Right. Yeah. I mean, for folks that are just going off and writing up templates, doing live views, that sort of thing, nothing. You can do a huge amount of that and in near complete ignorance of how HTTP works, which is, I mean, again, as it should be, right? This is the reason that we have a layered approach to stacks. And the reason we have abstractions is so that most people on one side of the abstraction don't have to, look across it.
Mm-hmm.
They can just deal with the abstraction as it is. And so for the folks that use live view as an abstraction or even use Phoenix itself as an abstraction, they shouldn't care. But there's some neat new things that have come out of this. And in fact, I'm giving a talk as we record this. I'm giving a talk next week. I think once this is released, that I will have given it the week past at ElixirConf EU, where I talk about kind of some of these changes within Cowboy or within Phoenix rather, and the things that they enable you to do. And one of the really interesting things that I think people probably will make use of is the fact that as of 1.7, you can now interact with WebSockets inside Phoenix at the bare lowest protocol level. You can actually send individual frames back and forth if you choose to, binary frames or text frames or what have you. Because previously that has all been abstracted away by channels within Phoenix. And then LiveView sits on top of that, there's transports in there as well. You were actually, prior to 1.7, literally not able to do this in Phoenix. You could not interact with a WebSocket at a really low level. And the thing that I think is kind of useful for this is that if you are doing something like I've done this at a previous employer where we had an existing front end, we didn't want to touch the front end, we just wanted to change the implementation of the WebSocket server behind the scenes. You can use Phoenix for that now. You can, if you have, a situation where you don't want to go whole hog with Phoenix, you don't want to use live views, you don't want to use channels or presence or anything, you just kind of want to replace an existing WebSocket server with Phoenix, you can do that now just about trivially. Whereas prior to 1.7, that literally was not possible.
Mm-hmm. Yeah, I could see that being useful if you have, like you said, like an existing WebSocket client, right? That you couldn't kind of force into Phoenix before 1.7.
Yeah. And I think the few people that ever had to do that used things like main proxy and then kind of had their own little Cowboy dispatcher on the side that I would imagine in those cases was probably written once and then stuck into a corner and largely ignored by everybody. But the fact that you can do that first class within Phoenix, like I do a demo in that talk where I live code a bare WebSocket inside Phoenix, like a router and all, in probably 90 seconds front to back, without even a Phoenix restart. Because the router just picks it up. It's a live reload. It's a pretty useful thing.
Is there an advantage now to having Bandit be an Elixir rather than Cowboy being an Erlang to anyone involved in any of this?
No, everything, the whole point, and again, when I spoke earlier about playing for the other team for a while, the whole point of abstractions, or like generic abstractions like this, is that you don't need to care about the implementation, right? So like it's really important to me that like the Cowboy experience with this is just as solid as the Bandit experience, right? If it isn't, there's frankly just not going to be an adoption, because like Cowboy's numbers dwarf Bandit's, at least for the time being. In terms of, from an experience perspective, no. From a user experience perspective. From a development perspective, I mean, Elixir's about, I don't know, non-scientifically 75,000 times easier to read than Erlang is. So, that's a feature. Frankly, we have feature parity with Erlang, and something like, it's been a while since I've run the numbers, but I think it was something like half the line count. Maybe it was 1/3 the line count of Cowboy. So there's just a whole lot less there, and it's, like I say, it's a much more maintained stack, much more approachable and readable. We have the full power and luxury of being able to pull in, for example, the plug library has a helper module called plug.ssl that contains a couple of functions that codify some best practices around setting up SSL ciphers, ensuring just basically they run sanity checks on your SSL configuration to make sure that you're not deploying a server that is obviously wrong in some kind of way. And that's Erlang, that's Elixir code, obviously, because it's part of the plug library. And Bandit just uses it because we can reach over to whatever Elixir libraries we want to for that. So the ability to kind of lean on other libraries. We share some HTTP2 header compression code with the Finch library. We use the same header compression code on both the libraries. There's just bits like that where you can kind of do software development in a more of a best practices way in terms of, reusing code and abstracting the things and releasing the things as separate libraries. That might make sense for that.
Right. That's what I've always liked about the layering stack of networking and thinking about the various, OSI model or other interpretations of that, and be able to think about each piece building on the one before it. But am I understanding the Bandit README correctly here? You also wrote an entirely pure Elixir socket server to build all of this on top of?
Yeah, so all of this sits on top of, naming malapropisms aside, it's called Thousand Island, right? Because the equivalence in Cowboy sits on top of a socket server called Ranch, right? Because cowboys live on ranches. Bandit sits on top of Thousand Island because Bandit is to Cowboy as Thousand Island is to Ranch. Thousand Island, Ranch are both salad dressings.
Sure.
Bandit and Cowboy. Malapropisms are kind of my thing. So, it made sense at the time. Like when I say this whole thing started off as a joke, like I mean that quite sincerely.
I'm glad we've landed on naming things, because I enjoy naming things, and I can just tell from your projects that maybe this is the favorite part of the whole cycle, is just picking a name for the project, because there's so much thought.
It's the second best part. The best part is these. You guys can't see them, I guess, because it's a podcast, but I had stickers made for ElixirCon.
Oh, awesome. Those are cool.
Yeah, so making logos. Sorry, Owen, I didn't mean to interrupt you.
Oh, absolutely. I think the first time you popped up on my radar, I was watching ElixirConf talks a few years ago, and you were talking about SCEDX, right?
Yeah, that was at MPEX 2018, I think. 2017, maybe. Yeah.
Yeah, so this is a scheduling package for Elixir, and it's another pun based on like FedEx, which I don't know if we can actually say out loud, but you've not been pursued by any kind of legal entities about the name of that or any other packages, right?
No, and that, I mean, if you go to the SCEDX project too, the logo is a straight rip off of the classic FedEx logo. So
classic
stickers, and we have stickers for that and all. So yeah, naming definitely is one of the most fun parts of building these things, if I'm being honest. Naming and making stickers.
Making stickers and naming things, yes. So I always love a pun. That's the best part of my day, is whenever I can land a good pun. The effort on these names is definitely appreciated by me and all the pun lovers in our community. We've touched on a little bit about HTTP. HTTP2 has been mentioned. So the evolution of HTTP is something I'm kind of curious about. For years, we've been working with 1.1, then 2 came along some years ago, and HTTP3 is starting to pick up steam, it seems. How is that affecting your development of Bandit? Does it support 2 and not 3, or vice versa?
Yeah, so we have full support for HTTP1 and HTTP2. They are completely different on the wire. And the implementations of them are like, they're completely distinct stacks within Bandit. They're entirely different clusters of modules within Bandit. And there's really not a huge amount that you can share from an implementation perspective. Like they are just fundamentally very different from each other. The semantics are very similar from a user perspective. That was the goal of, as I understand it, that was the goal of HTTP2, right? From a user's perspective, they don't really see any changes to it. It's still request response based. You still request a URI with a verb. There's still headers go in each direction. You request bodies and response bodies. Like the broad semantics of it are identical, or at least largely identical. The implementation in terms of what the bits and bytes are that get sent on the wire is completely different. So that was quite a bit of work. I mean, HTTP 1, for the original purposes of this as the backing system for HomeKit, I only ever needed HTTP 1. And that, like, I've often said this, this is when I'm going to put my ranting old man hat, my old man yells at cloud hat on for a minute here. I've often said that any sort of standard that's worth using on the internet should be something that, the benchmark I've always used is it should be something a third or fourth year student can do as a term project. And maybe not the most battle hardened, ready for production, bet the company on it, but like you should be able to build an HTTP server as a term project for someone that knows their way around a language. And then, so HTTP 1 was kind of classic for that. It's kind of like of the original era of internet protocols, right? It is text on the wire. You can telnet to port 80 on a server, and you can type in, GET space / HTTPT / 1.1, enter.
Yeah, I love doing that to show people what it is, right? It's like, look, I open up telnet. This has nothing to do with your browser, and yet I can talk to a web server as if I'm a browser.
And so you can do that, right? And it turns out that for years, I actually thought that was the gold standard. That's what you wanted to do. And so in contrast to that, HTTP2 is what's called a frame-based protocol. So it's all binary-based, like in a frame is like, I think there's 3 bytes of length and then 1 byte that's of flags with foot. Like you need to actually go and tease it apart bit by bit, like literally bit by bit to make sense of it. You can't telnet to an HTTP2 server and do the same thing. I'd thought for ages, I was like, this is just, needlessly complicated. And the only people that benefit from this are like the Googles and the Amazons and the Facebooks of the world, because like this stuff is useful at scale, but it just gets in the way of the smaller people that are just trying to get things done. And then when I actually went and wrote these things, I realized that one of the things that's nice about that approach is that I mentioned earlier that the WebSocket protocol is really underspecified. It doesn't hold a candle to how underspecified HTTP 1.1 is. There are so many places in that, like you can't throw a stone at the HTTP RFCs without finding a place where you could validly choose this or that. And, oftentimes they're completely opposite directions on a given choice. It's wildly underspecified. And so it's really difficult, for example, to be able to have a confidence that like you've implemented the protocol correctly. Like HTTP2 has Bandit runs, it's called H2 spec is the name of the project. It's a Go project that just codifies a few hundred different test cases about various corners of the protocol. And we run that as part of CI. So if we break HTTP2, I'll know instantly. Like the code won't even make it into main. There's no such equivalent. And there's actually other testing suites for HTTP2 as well. H2 spec was just the one that we chose. There are none for HTTP1. There is no such thing as like a gold standard conformance suite for HTTP1 because there's so many, it could be this or that. You could encode a content length as a binary, or you could encode it as a binary in commas and take the last, like there's a million places where the protocol does that sort of thing.
I'm sure we've all seen, right, like a commented line in like an Apache config or something, right? Like this header is replicated here because IE whatever or IIS whatever, right? So you had these kind of weird overlaps, and yeah, it's interesting. I think the kind of like CI test case you're talking about there from hey, let's push the envelope of your server to make sure it's good. Like that's a really neat way to validate.
Yeah. There's another one for WebSockets called Autobahn that we run as well. So WebSocket and HTTP2 stacks are covered in CI exhaustively. If we break them, we'll find out. And like I say, the code won't even make it into production. HTTP1 being far and away the most important of the stacks and having, from that perspective, far and away the worst coverage from a conformance perspective, is something that I'd like to change. I think one of these days I might get around to writing a conformance library for HTTP1. I'm not the first person to ask for it. There's a number of and not even within the Elixir world, there's a number of folks like Jacob Rothstein over in the Rust world has looked for something like that as well. I know there's a couple of people in the Go community that are asking for these things. Like they just don't exist, which is frankly to me shocking.
Yeah, considering that basically the entire world right now runs on HTTP 1.1.
Yeah, right. And will probably forever. Like, again, HTTP 2 is important to the Googles and the Facebooks of the world, but not to you and I.
So I'm curious, a couple things about these new evolving protocols. The first one is, really, this is just an excuse for me to bring up my favorite engineering resource, HTTPcat, http.cat. This is a super helpful guide for understanding all the different types of response codes that you might get from a server. Do these response codes change with these new protocols, or are they identical?
They're generally identical, and big ups to HTTPcat. I used it just the other day. Someone was asking an issue on Bandit about header length validation. I was like, yeah, it's a 431. And then I literally just put the HTTPcat reference to it. By and large, yes, they are where they make sense, where the semantics continue to make sense. There's a couple of codes. Let me think of an example. 101, switching protocols. HTTP 101 switching protocols doesn't make sense. Protocol switching is specifically out of scope in HTTP 2. It's not something that the protocol supports. So returning a 101 on an HTTP 2 connection is like a logical inconsistency. But any of the standard 200s, 204s, 404s, they mean the same thing in both of them.
So a WebSocket to this day is still going to start with HTTP 1.1.
There actually is a standard. I can't remember the RFC offhand. It's somewhere in the 8,000s about upgrade. HTTP 2 has an upgrade function. It's built into the protocol as opposed to built into the application.
I see.
So you can upgrade HTTP 2 connections to WebSockets. It's a thing apart from that semantic. And it's a thing that just about nobody supports. Finch supports it on the client side. And I think one of the Go web servers supports it as well on the server side, but I think that's about it. I'm going to land it eventually when the time comes once I'm past 1.0. I'm going to land support for it, but it's not a thing that anybody uses. It's mostly just going to be there for completion.
So one of I'm flashing back to a few years ago, the introduction of Live View and starting to understand anything about WebSockets at all. And what was interesting to me at the outset was you're talking about a persistent connection. You authenticate a user once to identify who the person is. And then anything else you do within the app can be authorized and so on. But you don't have to keep asking every time someone clicks a button, like, who are you? Like you would with a spa app, for example, that's making a bunch of AJAX requests. So how does that change? Does HTTP 2 or 3 or Quick or something else in the future, are any of those kind of more of a persistent connection type model, or is it kind of a different thing entirely?
Well, okay. So when I mentioned that from a semantic perspective, that 1 and 2 are identical, they're both fundamentally request response protocols, right? And they're stateless, and the term of art for it is that they're stateless, right? So like, just because I've made a request on this, on this TCP connection, via it over HTTP 1 or 2, any subsequent requests I make are completely divorced from any previous requests that I've made. You can't generally forward things through. Ironically, that was actually the requirement to be able to do that, was the thing that I needed from HAP in the first place to be able to do that HomeKit thing. So Bandit does support it. It has an escape hatch for that, largely because of that, but it's not fundamentally something that like HTTP does. The reason why that works with WebSockets, and this is a bit of an interesting digression into the Elixir process model here. When you make a WebSocket connection, it starts life as an HTTP connection. And in fact, as of plug 1.14, the original upgrade gets surfaced to Phoenix as a plug request. It gets pushed through the Phoenix router the same way any other HTTP request does. And then Phoenix will indicate that it wants to upgrade that request by calling plug.con.upgradeAdapter, the same as you have like plug.con.sendResp or sendResp headers or what have you. There's an upgrade adapter function, and that is basically how you handle the upgrade. So it's a plug initially that has access to everything in the connection. It has, you can grab the user session, you can pull stuff out of the session store, you can do whatever you'd like to do with that. And then you build some state and you hand that state off to your WebSocket handler, to your WebSock handler. And then the WebSock handler looks and acts, and in fact, at least in the case of Bandit, is actually implemented as a gen server. And then so that state that you pass in is the state that you start the WebSocket gen server off with. And then every time connections come in from the messages come in from the client, they just show up to you as a handle in function that, again, is the exact same semantics as a gen server. And then so to your point about how that state works, you don't have to re-authenticate every time because whatever authentication information you might have about the user is in your socket state. And that, gets sent back, gets passed back to you every time the same way it does with a gen server.
So is that WebSocket process, the gen server, is that also the live view process whenever that live view is up and running, or is it a separate process?
No, it's a separate one within live view. It's the Bandit connection process. I go into some pretty in-depth detail about this in my MPEX Mountain Talk from last year. That's actually where I first met you in person, Owen, in Utah last year. That was MPEX 2022, I think. The talk's called A Funny Thing Happened on the Way to the Phoenix. I spend about 30 or 40 minutes in there going pretty in-depth into the process models for these things. I mentioned that largely because I don't want to get too in the weeds with it, but it's also a super interesting case study in how the OTP process model fits really, really well to networking. You'd be hard pressed to design a process model that made more sense for this than what OTP already does. It's just about perfect for it.
It's almost like they designed it for distribution and networking. Yes.
It's almost like they knew what they were doing. Yeah. And then so that process that represents that connection in the OTP networking world, that networking process is the WebSocket connection, at least within Bandit anyway.
Cool. So I've also done a little bit of research into, I can't say I've fully wrapped my mind around HTTP 3 or Quick. I have glanced at some things like web transport, which I think would be an alternative more to WebSockets. And I'm kind of curious how much you keep your ear to the ground as you're working entirely in the back end here with the transport stack. Are you aware of these things?
Oh, very much so. Very much so. The tricky thing with HTTP 3 is that everything previous to that, HTTP, HTTP2, WebSockets, WebSockets, they all run on top of TCP, right? And so if you've heard of the distinction before between TCP and UDP, they're two different protocols. TCP is like a reliable, long-lived connection, right? So you basically make a TCP connection to a server, and then you have this durable connection with the server that may last for a few seconds, it may last for days, right? But it's this durable, to come back to it, it's a stateful connection, right? There's a state to that connection that exists that both the client and the server know about. In contrast to that, UDP is a stateless protocol. So it basically, every message that gets sent or received in either direction is its kind of it's its own island. It doesn't know anything about any other connections, any other packets that may have been sent in the past. Every one of them is its own kind of standalone little nugget of information. Everything that's been written in the HTTP world before HTTP 3 is based on TCP. So it's based on this fundamentally, you make a connection to a server, you run a bunch of, you send, again, capital GET/HTTPT, blah, 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 blah. You're sending a bunch of data to a server, and then the server sends on that same connection, sends that response back to you. HTTP 3 it's a completely different, it's based on Quick, which is in turn based on UDP, and it builds those same general long-lived connection ideas, but it does it on top of UDP for, again, a bunch of reasons that mostly accrue to the Googles and the Facebooks of the world, right? This is a thing that makes their lives better at scale and not so much ours. And I mean, I ate crow about this once, so maybe I'll eat crow about it again when I finally go and implement this stuff, but it's fundamentally a very, very different protocol is the short version of this, right? To implement HTTP 3, you have to implement Quick. To implement Quick, you have to have a UDP stack. To implement a UDP stack, you basically have to go all the way back to almost to first principles to do this. And again, if you're Google and you're writing Chrome and you have, I don't even know how many thousand engineers they have, that they maintain the bits of Chrome, great, cool. You have an entire team that does your UDP stack, right? And then they can coordinate with an entire team that runs Quick on top of that. If you're one guy just trying to write this on top of like the basic Erlang libraries, you're going to have a bad time with it. So I very much would like to write an HTTP 3 library, like HTTP 3 support in Bandit. I'm frankly at this point just not sure what that looks like. If it's even a task that's achievable.
Now, I want to make a comparison, and you can tell me how wrong this is, but the way I like to think of TCP versus UDP is in gen server terms, right? So you can make calls and you can cast. So you can either call or cast in a gen server. A TCP, to me, sounds a lot like using a call. You're going to send something to the gen server and wait for that response. With UDP, you're going to cast, and it may or may not succeed, but you're going to keep moving and not kind of wait for that response.
Yeah, that's a very apt metaphor. What I am really keen to see about is to what extent Erlang itself, OTP ends up supporting Quick. I think architecturally the correct thing to do would be to, and like I say, I think because I haven't actually sat down and like really puzzled this out yet, I think they're architecturally the team that should be owning a Quick implementation. And then Bandit would in turn write an HTTP3 implementation on top of their Quick library.
Okay. Yeah. I was gonna ask, it sounds like for a lot of these things, like you say, these evolutions, these protocols have benefit to people who control both sides of the equation or are doing things at kind of massive scales where this matters. Where do you want to see things go then for the rest of us? And what are you hoping to see from either the protocols or the language or things like that? And so it sounds like your ask, at least, or your pondering and kind of thought processes, maybe some of this support needs to start down at the Erlang layer, at least in terms of Quick and UDP. But anything else, looking at Phoenix, looking at LiveView, looking at how these things are taken off, what are you hoping comes down the pike, or what challenge do you want to take on next?
Personally, there's a few loose ends that we left in the Phoenix stack as part of the work about adding WebSocket support. There's a couple of loose ends there that I'm going to pick up on. And I do have, this is something that isn't public knowledge as the day we're recording it, but by the time this comes out, Bandit is now in the 1.0 pre-release series. So it's now a stable project that won't be changing in substantial ways. I've got a list, I'm just looking at it on my screen right now, of probably 25, maybe 30 items of things that are still going to be backwards compatible, but are just like little improvements here and there. Paper cuts within Bandit, adding support, WebSockets over HTTP2. We were talking about that earlier. A couple of things in telemetry. We still haven't totally proofed that stuff out. There's no shortage of little things that can always be better. The funny thing is that from a day-to-day perspective, I don't actually I use Phoenix as an API server just because architecturally we just have a React front end at PagerDuty. So to the extent that I do front end work, it's always in React. The changes to LiveView and the changes even to any of the stuff with components in 1.7, I find it really exciting and I think it's really great, but like I have no personal skin in the game in that respect.
So you're not a Tailwind guy is what I'm hearing. You're strictly API.
The degree to which I am hopeless in the front end world should alarm you, honestly. Like I am, what's that thing about not only am I the president, I'm also a customer. Yeah, I'm just the president here. I'm not a customer. I don't actually use most of this stuff.
But you're doing some important work, right? You're doing work that supports the rest of the community who's building, the front end and even REST or GraphQL APIs over these protocols. And these protocols are evolving in a way that are supposed to help us with kind of the evolving nature of connectivity as well. I know anytime I watch my phone try to switch from Wi-Fi to 5G or 4G and back, it's always a mess. Do these protocols help us at all with the transitioning between different connections?
Quick, without getting into the weeds, it works on top of UDP, right? So every bit of information that a Quick client or server sends back and forth to each other is distinct from the rest of them. And the way that they've implemented that, they have these kind of identifiers that are in the message itself that say, I know you don't know about connection ABC, but here's the next thing about it. And that might come from anywhere. It might come on the same connection. It might come from on a different network. One might come over your 5G and the next one might come over your Wi-Fi. They are transparent for that. So the theory of all of this is that you can be running a logical connection from a web page running over HTTP3 to a server on your phone, on Wi-Fi. Then you can roam, you can get into a car or whatever. You can roam onto 5G, you can get on a plane, you can come back. And that connection should be, the promise of it at least, is that connection continues to be at the level above that, at the abstraction above all of the protocol stuff from a Phoenix applications perspective, is a single durable connection on top of that.
Right.
Remains to be seen how much that actually works out in practice. This wasn't the first stack that has promised this, but that is the promise of it.
Streams are involved. The format of these messages sounds interesting. I think we're going to have to start resting on the laurels of resources on the internet to get any further into the weeds here. So
I think so, yeah. If anybody is interested in this stuff, I'm really dogmatic within Bandit about linking to the relevant RFCs. In all of the test cases, I call out to the relevant clause in the relevant RFC. And where possible, I surface error messages that reference them as well. And there's links in the Bandit README to all of the relevant RFCs as well. So if you are curious to start digging on this, it's as good a jumping off point as any.
I have long recommended people read RFCs. Always, it's great. It's a really interesting experience to read RFCs.
Yeah, I agree.
And I'm sure even the source code for Bandit would help someone understand HTTP, the different protocols that have been implemented there, just kind of reading through the code, watching how, the data gets passed.
Yeah. And I mean, honestly, like there's not, and I've been pounding the table about this at basically every chance that I get, that this stuff is not fundamentally complicated. The entire extent of Bandit is, I think, 5,000 lines. It's not that big of a project. There's nothing kind of behind the curtain there. There's no other giant library that does all the heavy lifting on this. Like writing a web server isn't actually that hard. You need some stick-to-itiveness and some persistence and a structured way to approach solving successively, larger and larger problems. But it's just code, right? I mean, all of this stuff at the end of the day, all we're doing is sending zeros and ones over a wire.
Right. Well, cool. Before we wrap up, do you have any final plugs or asks for the audience?
Take a look at Bandit. Always keen to pound the table on that one. It's, like I say, pretty straightforward for someone to be able to implement and start using. The volume and the nuance of the bug reports that we started getting on the Bandit project once we had Phoenix support was just leaps and bounds larger. It really does help these projects to have users, and to have people that report bugs back. We've gotten some really deeply obscure bugs that were not things that from a development perspective I ever would have done. I never would have thought to have tested some random permutation of configuration options or what have you that someone happens to report a bug on. And it's a legitimate thing to fix, but it's just, there's an awful lot of development that happens and should happen as a response to, to bug reports. And that scales pretty directly with the number of people using it. So y'all should be using it.
Awesome. Well, thank you so much for putting in, at this point, years of work, improving and enhancing and helping evolve the stack that Phoenix is built on. And thank you for helping us unpack everything there is to know about web protocols.
You're very welcome. Thanks for having me. Great to be here.
Elixir Wizards is a production of Smart Logic.
You can find us online at smartlogic.io, and we're at smartlogic on Twitter.
Don't forget to like, subscribe, and leave a review.
This episode was produced and edited by Paloma Pechenik for Smart Logic.
We'll see you next week for more on the next 10 years of Elixir.
Hey, this is Yair Flicker, president of SmartLogic, the company that brings you this podcast. SmartLogic is a consulting company that helps our clients accelerate the pace of their product development. We build custom software applications for our clients, typically using Phoenix and Elixir, Rails, React, and Flutter for mobile app development. We're always happy to get acquainted, even if there isn't an immediate need or opportunity. And of course, referrals are always greatly appreciated. Please email contact@smartlogic.io to chat. Thanks, and have a great day.